Okay, the equation for the distance that can be seen from a periscope is d of h equals 1.22 square root h, where d is the distance in miles and h is the altitude in feet. How far can you see if you are at an altitude of 10,000 feet? Is there someone who can explain how to answer the first question? What would I need to do? Tyler?
Well, I used my calculator. I just put the equation in my y equals thing and asked for 10,000.
What do you mean you asked for 10,000?
Like I went to the table set, switched the thing to ask, and put in 10,000 feet
for the h. Oh,
yeah.
Okay, yeah, gotcha. Okay, so isn't that also the same thing as?
I mean, you could whatever.
Yeah.
It's funner with the calculator.
It is more fun with the calculator, isn't it? Okay. All right. So when you do that, watch this. Dun dun dun. Oh, hit the wrong thing. 100 and wouldn't it be 122? Did I forget my? I did. My bad. Okay. How about the second question? At what altitude will you be able to see 100 miles? How would you do this? Stephanie, did you get this one?
I substituted 100 for d of h.
Okay, so you said 100 equals 1.22 square root h. Okay, so let me use my handy dandy calculator and take 100 divided by 1.22. Now, what I want you guys to get used to is on the calculator screen itself, you see the decimal the whole way out. Don't round it. And now, what would I need to do to both sides of this equation to find h? Square it. So guess what? With that on my screen, just press x squared, and it pulls it up for you. So I square both sides, and we get 6,718.624 feet. Remember we talked about rounding 3 places? Okay. Something else I want to talk about is sometimes students have trouble with d of h. Like they want to put 100, like d times 100 or something. What does d of h actually mean, like in the context of this problem?
Distance compared to height, like how far you can see compared to how high you are, and then the h's are.
Exactly. Okay, this really is saying what d of h means. What is the distance at that height? Okay, that's actually what it means. All right, so moving right along. So that was just to sort of motivate what we're going to do today. So relation. A relation is a set of ordered pairs. And I have 4 examples here for you to jot down. The first example is literally a set of ordered pairs. 1, 2, 0, 3, negative 1, 0, negative 3, negative 2. That's an example of a relation, a set of ordered pairs. The second example I have is the equation y equals 2x plus 1. The third example I have is a mapping diagram where I have inputs A, B, C and outputs 1, 2, 3. And then the lines are really saying I have A, 2, B, 1, C, 3. So that's a relation. And then the fourth one is a grid where I have plotted 4 points. Okay, they really can be represented as a set of ordered pairs. A function. A function is a relation in which each input has exactly one output. Examples, a line is a function. Well, an oblique line, a slanted line, y equals 2x plus 1. What's an example of a line that's not a function? a vertical line. Your horizontal lines are functions, your oblique lines are functions. All right, another example of a function is this set of ordered pairs 0, 3, 5, 2, -1, 3. A non-example is 1, 2, 6, 5, 1, 4. Why is that one a non-example? Why is this one not a function? Josh?
Because the x input of 1 has 2 outputs.
Yeah. The input of 1 has 2 different outputs, okay? All right, now, my next example says, which of the following equations represents y as a function of x? So I'm going to give you a moment. I want you to think about it, maybe do some manipulations. In letter A, we have 2x squared minus y plus 1 equals 0. And in B, we have y squared equals 6 minus x. What do you know about a function? How can you determine whether we have a function? All right, let's look at letter A. 2x squared minus y plus 1 equals 0. Abby, what did you think about this one? Did you think it was a function or not a function? It is a function. How did you come up with that conclusion?
Because isn't it's a parabola?
Yeah,
And it passes the line test.
good. All right, if you solve this for y, it's 2x squared plus 1. We know that's a parabola that opens up, and she's absolutely right. It's going to pass our vertical line test. So it's yes. How about in letter B? Rachel, what do you think about B?
I said no.
You said no. Okay, why do you think it's no?
Well, because if you took the square root, I didn't think you could have square root in a function.
Okay, we can have a square root, but you do have to be careful that it's y equals plus or minus the square root of 6 minus x. Let's think about this. If I wanted to graph this, because maybe immediately I don't know what it looks like, and so there's actually 2 pieces to it. And if I start with that x is 6, I would get 0. And what about if I plugged in 5? What's 6 minus 5? 1. The square root 1 is 1. Now, I don't want to plug in a 4 because I don't want to do square root 2. But what if I went to x is 2? If x is 2, 6 minus 2 is 4. So connecting our domain idea, this is a square root that's moving left. And then if you stick a negative out front, do you remember that just makes it a reflection? So this is a parabola that opens right or left, and something I could mention is that anytime you have a y squared with an x to the first, it's a parabola that opens left, right, and this one's going to fail the vertical line test, okay? So if you don't know exactly what it looks like, you can visualize it, yeah.
What if, like, never mind. I changed my mind.
Okay. You could also do a table of values, and if you could get inputs for x to spit out two y values, you could also do it with a table. That would work. All right, recall y equals 2x plus 1 can be written using function notation. F of x equals 2x plus 1. So I'm going to change colors here and do this over here. So if you want f of 3 and your x cubed minus 4x. So this is 3 cubed minus 4 times 3. So when you want to do f of 3, you're replacing the x everywhere with the 3. And letter B, for some reason this bothers us if we're not putting a number in. What would f of A be? Abby?
Would it be a cubed minus 4a?
Yeah, everywhere you see the x, you're replacing it with an a. So, do you remember last year when we did the function machine and I had the box? We held up the box. That was our function machine. It was just an empty paper box. And we were putting things in and having the things spit out of it. Well, I want you to think about this, that if we're putting x plus h, that is still replace the x with an x plus h. But you have to replace every x that you see. So this becomes x plus h cubed minus 4 times x plus h. Now let's do this the easy way. Do you remember last year I showed you Pascal's triangle? Do you remember Pascal's triangle where it went like this? Well, if you want to take something cubed, so to do my x plus h cubed, it's 1x cubed plus 3x squared h plus 3xh squared plus 1h cubed. And then we'll finish this up with a minus 4x minus 4h. 1, 3, 3, 1 are the coefficients, and it starts x cubed, x squared, x, then no x. Okay? And then I don't believe we have any like terms. That's it. Okay? All right, questions on replacing the x with x plus h? Or are we bothered by x plus h cubed? That's an algebra 2 thing we've done. Remember that? Remember that now? Okay. Next example. This is a piecewise function. And I recently covered this in algebra 2, and I know a few of them are struggling with it. F of x is x plus 1 when x is greater than or equal to 0, but it's negative x when x is less than 0. It says find f of 2. Now, I keep having students who plug 2 into both rows. Why can you not plug the 2 into both rows? Why does that not work? Tyler?
Because 2 is greater than 0, so if x is less than 0, then that won't work.
Exactly. Okay, if x is 2, you can't plug it in the bottom row because those are only allowed to have x values less than 1. So, to do part A, f of 2, you have to go to the top row, so it's 2 plus 1, which is 3. In part B, f of negative 5, I can't plug that in the top row. I have to go to the bottom row, and it's the opposite of negative 5. So it's 5. Does that make sense? That when you work with a piecewise graph, there's only one row you can plug into where you're going to have an allowable value. All right, domain of a function. The domain of a function is the set of allowable values for x. Recall, fractions cannot have 0 in the denominator, and let's change this radicals to even roots. Even roots cannot be negative. Because really, if it were a cube root, I can do cube root negative 8, I can do cube root negative 64, cube root negative 27. Alright, so let me give you a head start on me. And in the next example, it says find the domain of the following functions. There's an A, B, C, and D. What you need to remember is that fractions cannot have 0 in the denominator, and even roots cannot be negative underneath. So go ahead and try those 4. Today, this is a one-day lesson, so this homework is due on Monday. 1.4, we're going to spend 2 days on that section, but you will also get a worksheet that goes with it. Then we'll review Wednesday with a quiz Thursday. All right, let's look at letter A together. That's a polynomial. So Lydia, what do you think the domain would be? What are the allowable values you can plug in for x? You didn't do that one. Adam, did you get it?
Which one?
A.
A. Negative 1 is less than or equal to x, which is less than or equal to 1.
Okay, can you explain why you chose those?
No.
No? Ben?
Don't look at me. I don't know.
Abby, what do you think? Emily? Any ideas? Emily? No? Rachel? It is all real numbers, you guys.
I put that and I was so unsure.
Yeah. Okay, you guys, let's go back. Domain are the allowable values you can plug in. The only problems are fractions and even radicals. So then everything else is okay. So you can plug anything in. So this now plugging into an equation, of course. So let's go ahead and practice, and I like how Adam read his, we can go with interval notation. Okay. So how about B? John, what do you think about B? What can't I plug in?
Negative 2.
Okay, so we know x can't be negative 2 because that makes that denominator 0. But let's watch how we can do that in interval notation. This is negative infinity to negative 2 union negative 2 to infinity. All right, Stephanie, how about C? If I have an even root and it can't be negative under there, what did you get? I'm sorry, what?
X is greater than 5.
X is greater than 5? How'd you do that?
I have less.
Okay, so you're going to set x minus 5 is greater than or equal to 0. So you subtract. And I'm getting x is less than or equal to 5. So that would be negative infinity to 5 with a bracket. So when it says radicals can't be negative, you're setting what's underneath there greater than or equal to 0. All right. Katie, what did you write down for the domain in letter D? Okay. Well, what's different about D than the other 3? It's not an equation, so it's actually not going to be all real numbers. If domain represents the allowable values for x, What are the allowable values then, John?
Would it be the first number in the parentheses?
Yeah. So 1, -3, 4, and 0. That's it. All right, last one. F of x equals x squared plus x minus 1, and we want to find, this is called the difference quotient. We're going to work on this all year long because it's going to help us with calculus, okay? So here we go. We tried this earlier. When you want to do f of x plus h, you're replacing the x everywhere with x plus h. So watch. This is going to go x plus h squared plus x plus h minus 1. And I'm going to pause here a moment. So you can write that down. And then look. All I've done is in f of x, I've replaced each x. I'm just doing a substitution. I'm pulling the x out and putting x plus h. So what I have written down is just the f of x plus h. That's it. Does everybody understand that that's f of x plus h? Now we're going to do minus, and here's f of x. The nice thing is, once we're done with this, everything should end up canceling except the terms with an h, because that's just the way that this works. So I get x squared plus 2xh plus h squared plus x plus h minus 1. Now I'm going to distribute the minus sign. Okay, so now look, the x squared cancels, my 1 cancels, my x cancels, and I'm left with 2xh plus h squared plus h. So remember what I just said to you. I said after you kind of expand this and group together, everything cancels except the terms that have an h, which it did. So if you're working these out, and I'll tell you, put a star next to this, there's going to be a quiz problem that I ask you to do this. And then the next thing is, you factor out the h, and it will always have this common factor of h that's going to cancel. And you end up with 2x plus h plus 1. You really need to wait to calculus to figure out what we're going to do with this. On Monday, my calculus class is going to find out is the definition of the derivative uses this difference quotient. Okay?